Are you seriously preparing for tech interview? Then you must watch this full video.
Hey everyone, and welcome. Today we are diving deep into those SQL interview questions that are about so much more than just writing the right syntax. We're going to uncover the hidden logic that really separates a good answer from a great one. You'll see why thinking like the database itself is the absolute key to landing that job. So let's jump right in. This quote, it really gets to the heart of everything we're talking about today. See, interviewers don't just want to know if you can write a query. They want to know if you truly understand why it works the way it does. And let me tell you, mastering that distinction, that's what turns you from just another candidate into the one they absolutely have to hire. All right, let's kick things off with the absolute bedrock of database reliability, the transactional mindset. Seriously, understanding how SQL handles changes, what it makes permanent and what it holds in a temporary state, is often the very first hurdle in these interviews. And it's where a surprising number of people totally trip up. So let's imagine a classic scenario, like a bank transfer. A query runs and successfully deducts money from account number 1. But then, the very next query, the one that's supposed to deposit that money into account 2, fails. So the big question is, where's that money? Did it just vanish into thin air? Now, a lot of people's first instinct is to say, well, the first update is already saved, right? It's permanent. But SQL is built for safety above all else. The correct answer is that nothing is permanent until you give that final explicit approval with a commit. Without that command, the entire operation is just temporary, and it can be wiped out instantly with a rollback. The why behind this all comes down to a super important principle known as ACID. That's atomicity, consistency, isolation, and durability. Just think of it as the ultimate safety net for the database. It basically means all your changes are held in this temporary holding pattern until you're the one who says commit. This design is exactly what prevents disasters, like money leaving one account and never arriving in the other. It keeps the database totally consistent and reliable.
Okay, so this whole idea of a transactional safety net also applies when you're deleting data, which of course leads to the next logical question. If you run a delete command, is that it? Is that data gone for good?
And you might be surprised, but the answer is no, it's not gone forever. You see, delete is a DML, or data manipulation language command. Its job is to change the data inside a table, not the structure of the table itself. And because it's a DML command, it's part of a transaction. So if you haven't typed commit yet, you can just use rollback and poof, all that deleted data comes right back. So rolling back an entire transaction is obviously super powerful. But what about more complex situations? Imagine you've run 5 updates, but you realize only the last 2 were a mistake. Do you have to undo everything and start from scratch? Or can you be a little more surgical? You absolutely can. And this is where the SAVEPOINT command becomes your new best friend. You can literally place a named bookmark, a save point, anywhere you want inside your transaction. Then, if you mess up later on, you can just roll back to that specific point, and you get to keep all the correct work you did before it. It's an absolutely essential tool for those big multi-step operations. Okay, now let's talk about a real-world mystery that has made countless developers want to pull their hair out. You've made a mistake, you confidently type rollback, you hit enter, and nothing. Nothing happens. The bad data is still there. So what gives? Why didn't it work? Well, the culprit is almost always a sneaky little setting called Autocommit mode. It's a really common default in tools like dbeaver or SQL Workbench. And if it's turned on, every single statement you execute is treated as its own tiny transaction that gets finalized instantly. There's literally no open transaction left for you to roll back. Knowing this isn't just trivia, it is a real-world lifesaver. So far, we've seen that DML commands like update and delete can be reversed. But this brings us to a really crucial point. Not all SQL commands are transactional, and this leads us to the critical difference between DML and its much more powerful and permanent cousin, DDL. This right here might be the single most famous interview question on this whole topic. We just established that delete can be rolled back, but if you use the TRUNCATE command to empty a table, that action is final and permanent. Why is there a difference? The classic mistake here is to say that TRUNCATE is just a faster version of delete. And yeah, it is faster, but that's just a side effect. It's not the real reason. The actual answer goes way deeper into the fundamental structure of the database. The difference, as you can see here, is all about the type of language. Think of it like this. Delete is DML, data manipulation language. It's like rearranging the furniture inside a building. Truncate, on the other hand, is DDL, data definition language. That's like bringing in a wrecking ball and demolishing the building itself. Because DDL commands change the database structure, they automatically perform a commit, which makes the action totally permanent and irreversible. To put it another way, delete keeps a detailed log of every single row it removes, which is the paper trail that makes a rollback possible. Truncate just skips that whole process. It simply deallocates the data pages for the table, marking them as empty, which is way faster, but it's a completely non-transactional operation. It's not changing the content, it is redefining the entire container. Okay, for our final section, we're moving beyond the commands that you type yourself. We're going to look at the hidden logic that runs inside the database itself, things like triggers and functions. Triggers are a total double-edged sword. They're incredibly powerful, but they can also be really dangerous. A good interviewer isn't just going to ask you how they work. They're going to want to know if you have the wisdom to understand when they should be avoided altogether. So many candidates get this wrong. They think triggers are called manually like a procedure, or that there's some kind of performance booster. The truth is, they fire off automatically whenever data changes. And while that sounds useful, they can seriously slow down your database and become an absolute nightmare to debug when something goes wrong. Being able to voice that caution, that shows a level of experience and maturity that interviewers love to see. And this is exactly why they're so tricky. The logic isn't sitting in your application code where it's easy to see and debug. Nope, it's buried deep inside the database engine, acting like a ghost in the machine. So when a query is mysteriously slow or just failing for no reason, a forgotten trigger is very often the hidden culprit. All right, for our last topic, let's look at another common point of confusion. Why can you stick a custom function right inside a select statement, but you can't do the same thing with a stored procedure? The syntax might look similar, but the database sees them as completely different things. Let's find out why. This comparison really makes it crystal clear. A function is like a gumball machine. You put one thing in, and you are guaranteed to get exactly one thing out. A procedure is more like a Swiss Army knife. It can do a bunch of different things, update tables, write to a file, maybe even send an email, and it might return nothing at all. A select statement needs a predictable, single value for every single row, and only a function is designed to give that guarantee. So at the end of the day, the main takeaway is this. A senior-level SQL interview is not a memory test. It's a test of deep, fundamental understanding. The moment you can confidently explain what's happening behind the scenes, when you can answer the question behind the query, you prove you're not just a coder. You're a developer who truly gets the tools of the trade.